Hello students, welcome to EduRev. Have you ever wondered how sugar seems to vanish in your tea? Or how we get pure salt from seawater? Today we will explore mixtures and the clever ways scientists separate them. And I will guide you through key ideas and simple steps. We will meet different kinds of mixtures like solutions, suspensions, colloids, and learn methods such as crystallization, distillation, chromatography, and centrifugation. Let's begin gently with how mixtures are classified so everything else makes sense. A homogeneous mixture or solution looks the same throughout, so every sip tastes just like the first. Think of sugar dissolved in water or vinegar mixed in water as tidy, uniform blends. A heterogeneous mixture is different in different parts, like sand in water, where particles are visible and settle with time. These two categories help decide how we separate the components. So classification is the first useful step. Now let's look closer at solutions, where one substance dissolves in another. The dissolved substance is called the solute, and the dissolving liquid is the solvent. For example, sugar and water. The amount of solute in a given amount of solution is called concentration. And getting it right can be very important. For example, ORS must have precise amounts of salt and sugar in water to safely help someone who is dehydrated. We commonly express concentration as percent by mass, percent by volume, or mass by volume, each useful in different situations. Percentage mass tells us grams of solute per 100 grams of solution, which is common on food labels. Percent mass by volume tells us grams of solute per 100 milliliters of solution, often used for medicines. Volume by volume tells us milliliters of liquid solute per 100 milliliters of solution, useful for perfumes and some chemicals. Next, solubility tells us how much solute can dissolve in a fixed amount of solvent at a given temperature. A saturated solution cannot dissolve any more solute at that temperature, and heating or cooling can change how much dissolves. Many solids dissolve more when the temperature rises, while gases usually dissolve less as things get warmer. We can draw a solubility curve to see how solubility changes with temperature and predict when crystals will form. Speaking of crystals, crystallization is a gentle and powerful separation method for homogeneous solid-liquid mixtures. You make a saturated hot solution, filter out insoluble impurities, cool the clear liquid slowly, and watch pure crystals form. Slow cooling gives larger, well-shaped crystals, while quick cooling makes many small crystals. Salt from seawater and pure copper sulfate from lab solutions are good examples of crystallization at work. Distillation separates liquids by boiling and condensing, using their different boiling points to recover each component. Simple distillation works when boiling points differ a lot, and fractional distillation refines mixtures with closer boiling points, like crude oil fractions. Distillation has roots in history too. For example, Indian methods to extract fragrances from flowers. Chromatography is another elegant method that separates components by how fast they travel with the solvent on paper. A tiny spot of ink or plant pigment spreads and divides into colored bands as the solvent climbs the paper. This method is great for separating dyes and checking what's inside mixtures of many solutes. Now let's turn to heterogeneous mixtures and everyday techniques to separate them. Immiscible liquids like oil and water form layers and can be separated using a separating funnel by draining the denser layer first. Sublimation is a neat trick where a solid turns directly into vapor and then back to solid when cooled, useful for camphor or naphthalene. For mixtures with suspended particles, filtration or settling may work, but fine particles often need extra help. Centrifugation spins mixtures quickly, so heavier particles swing out and collect at the bottom, a method used in blood tests and labs. Coagulation adds a substance like alum to make tiny particles clump together so they settle and can be removed, a key step in water treatment. Let's pause for a moment on colloids, which sit between true solutions and suspensions and often look uniform to the eye. Colloid particles are small, do not settle, and scatter light, producing the Tyndall effect that makes a light beam visible in milk or fog. Unlike solutions, colloids show this light scattering, which helps us distinguish them in the lab or in everyday observations. Many familiar items are colloids. Milk, ice cream, mayonnaise, and even blood are all complex, useful mixtures. Throughout these methods, the guiding idea is simple. Use differences in physical properties like solubility, boiling point, particle size, or density to separate components. That insight links classroom experiments to industry and health. From purifying salt and sugar to making medicines and treating drinking water. A small device like a paperfuge can bring centrifugation to remote places, showing how simple ideas can save lives. Now a short recap to keep the main points close at hand. Classify mixtures first as homogeneous or heterogeneous, because the type guides the choice of method. For homogeneous mixtures, use crystallization, distillation, fractional distillation, or chromatography depending on the components. For heterogeneous mixtures, use separating funnels, filtration, sublimation, centrifugation, or coagulation as appropriate. Remember key terms: solute, solvent, concentration, solubility, suspension, colloid, and the Tyndall effect. And keep in mind that temperature, particle size, and density are the practical clues that help us pick a method. Thank you for staying curious and following this gentle tour through mixtures and their separation methods. I hope you feel more confident about how daily processes and big industries use these simple principles. If you enjoyed this overview, explore the full chapter and experiments on EduRev to see these methods in action. Come back for more hands-on tips and clear explanations to build both understanding and confidence. Goodbye for now. Keep observing the world around you. And remember that small differences often hold the key to big solutions.